All right, so we're continuing Unit 2. We're finishing up Chapter 11. This is Section 4. We're talking about how fast. So we've talked about distance and displacement and time intervals and how those are either scalar or vector quantities. But today we're going to talk about how we can use some of those pieces to talk about how fast something is going. So the first thing we're going to look at is position time graphs. And I'm just going to go over this briefly. We'll do a little bit more with this in class. The horizontal axis is your time. Remember, time is independent, and it will always be the independent, so it'll always be the x. And then your vertical axis is going to be position. So, and we'll talk a little bit more about this in a minute, but with position and time graphs, there are certain aspects that go into how fast something moves. So, when I talk about how fast, I'm talking about the speed of something. When I say speed, it's a ratio. Remember, ratio means that it is a division problem. The ratio of the distance an object moves to the amount of time the object is being moved. So we have two key pieces. We have distance and we have time. So when we talk about speed, we have a couple of different types of speed. We have what's known as instantaneous speed. So if you're going down the highway, your speed at that exact moment that you look at your speedometer, that's your instantaneous speed. Or we have what's known as average speed, and that's over a period of time. What is, the roundabout number that you're going? It might be 30, you might hit 60, the average between those might be 45. So the total distance traveled divided by the time it takes to travel that distance. So I'll say that again. The total distance traveled divided by the time it takes to travel that distance. So this is your first formula, okay? So average speed should equal the total distance divided by the total time. We can also write that as S equals D divided by T. You may see this on your reference packet as V, speed and velocity are very similar. We'll talk about that in just a moment. You might also see distance represented as an X because that is your, X is what we normally equate with a length or some distance. So you might see S equals D over T. You might see V equals X over T. Either one of those is the same formula for average speed. All right. Now, when we talk about distance and time, distance, of course, you know or should know at this point, is measured in meters. So we have meters in our numerator, and time for this class we're measuring in seconds. So we have meters in the numerator, seconds in the denominator. So when we pull that out into what speed is supposed to be, your final answer should be in meters/seconds, or what we call meters per second. All right? So that's what we're going to be using for this class because those are the SI units. So let's go ahead and let's jump in and look at an example. Let's say that while traveling on vacation, you measure the times and the distances that you traveled. Let's say on day 1 that you travel 35 kilometers in 0.4 hours, followed by 53 kilometers in 0.6 hours. I want to know what is your average speed. So I've given you distance, I've given you time. So what we need to come up with is what is the total distance and what is the total time. So looking at your distances, this is in kilometers, and for this problem, we're going to leave it in kilometers. We're not going to convert. That way it makes your math nice and easy. So total distance, we have 35 kilometers. That was our first one we came across. It says followed by 53 kilometers. So 35 and 53. That goes in our numerator. All right. Once we have that, we need our time. And our total time was we had 0.4 hours to start with, followed by 0.6 hours. So 0.4 plus 0.6. So when you go ahead and do the math for this, 35 plus 53, and if you have your calculator handy, you can go ahead and plug this in. 35 plus 53, you should get 88, and then 0.4 plus 0.6, you should get 1.0. So 88 divided by 1 is just 88. So as far as your number, 88's the answer. However, you need to include units. Units are going to be very important in this class. I will start deducting points if you do not put the correct units. So for this case, we had kilometers and we had hours. So your final answer should be 88 kilometers per hour. Moving on, there's a couple of practice problems that you can do. Let's talk through the first one. A person jogs 4.0 kilometers in 32 minutes, 2.0 kilometers in 22 minutes, and finally 1 kilometer in 16 minutes. What is the jogger's average speed in kilometers per minute? So we're not changing any of the numbers here. We're not converting. But I do want you to go ahead and figure this out. 4 kilometers plus 2 kilometers plus 1 kilometer. 4 plus 2, 6, plus 1 more, 7 kilometers. So 7 goes in the numerator. That goes up top. Then we need to add our minutes. 32 minutes plus 22 minutes. That gets us to 54. Then we need to add 16. So once we add 16, you should have 70 minutes. So we have 7 kilometers divided by 70 minutes. So 7 divided by 70, you should get 0.1. And that's 0.1 kilometers per minute. And you can plug that in your calculator just to figure out and double check. But that is correct. Number 2, I want you to do on your own. Make sure you put this in your notes. Please write this out. So a train travels 190 kilometers in 3 hours and then 120 kilometers in 2 hours. What's the average speed? Go ahead, figure that out, put the answer in your notes, and we'll talk about it tomorrow. A couple more things and we'll be done for today. Velocity is a key term. I told you we would come to velocity in just a few moments. Well, here we are. Velocity is the exact same thing as speed, except now we're including a direction. So speed might be that you're going 10 meters per second. Well, velocity is going to be 10 meters per second east, 10 meters per second north. It has that direction, just like we talked about with distance and displacement in the previous video. So velocity, because it has a number with units and a direction, is considered to be a vector. And once again, we are using meters per second as our unit. Now, when we graph motion, and again, I told you earlier we would come to this part, but when we're graphing motion and we're looking at a position time graph, again, position is our y-axis, our vertical, and our time is independent. It's our x-axis, our horizontal. We have also what's called distance time graphs. It's the exact same thing. Distance and position are the same, only position has a direction. All right, so distance time graphs. What happens with this is when we look at the slope of a line, you know that slope is equal to the rise divided by the run. Well, your rise is your y. Well, guess what? Your rise, your y, is distance. Your run, your x, is time. What do you know happens when you do distance divided by time? We just talked about it. That's the formula for speed or velocity. So when you find the slope of a distance time graph, your velocity is your distance divided by your time. Your slope is your distance divided by your time. So your slope on a distance time graph is velocity. And we'll take a look at some examples in class. But that's it for today.